Ever wondered how the internet works? Millions of requests per second, Netflix streams, Google searches, messages, payments, and it's all running on the same foundation, TCP/IP. I wanted to understand it, not just memorize it, so I decided to build it in C. The project followed the TCP/IP model. 5 layers, each layer only know about the layer above it and below it. At the bottom we have the physical layers, and that's the wires. Above it the link layer, that's the Ethernet frames and the MAC addresses. Right above it we have the network layer, the IP packets. Above it we have the transport layer, TCP UDP. And right on top we have our application. And each one of these layers have its own job, own structures and own files. For example, application layer doesn't know what an Ethernet frame is, and the link layer doesn't know what TCP is. And that is the whole point of layering. The first layer we're gonna talk about is the application layer. This is where the programs we use every day operates. For example, when you type a website address in your browser, it doesn't think about IP addresses and MAC addresses. It just says, I want this homepage. But one of the core protocols of this layer is HTTPS. Because the problem HTTP sends the data as plain text. This is where HTTPS comes. HTTPS is basically HTTP but with encryption. Before sending sensitive data, your browser and the server do a handshake and exchange encryption keys using asymmetrical encryption algorithm. After that, the data is encrypted before getting sent to the network. So when visiting a website, the application layer is responsible for creating the request and protected using protocols like HTTP and HTTPS. But the computer still needs a way to deliver the data. This is where the next layer comes in. The next layer is transport layer. Its job is to create communication between applications. Imagine your computer running many applications at the same time. When the data comes back to your computer, how do you know which applications need to receive it? The transport layer fixes this problem using ports. Now we reach network layer. Transport layer knows what application need to receive the data, but it doesn't know where the computer is located. This is the job of the IP. But before we can send messages through the internet, we have one small problem. Humans do not communicate in IP addresses. Nobody wants to remember an address like this. The system that translates this text to IP is called DNS. DNS, or domain name system, works like a phone book for the internet. We won't talk about how DNS works internally because that will need a whole other video. Moving on. Now your computer knows where to send the data. The network layer then adds the IP headers, the IP source and the IP destination. Routers around the world use this address to know where to forward the data. At this point, our data has become an IP packet. Now we have the destination IP, but there is still a problem. Your computer is connected to a local network. Before sending the packet to the internet, it has to send it to the next device, which is usually your router. However, local networks don't use IP, they communicate directly using MAC address. This is where ARP comes in. ARP, or Address Resolution Protocol, connects IP addresses with MAC addresses. Same as DNS, we won't go into details how it works. So now our frame will contain the destination MAC address, the source MAC address, and our IP packet. Now the data is ready to leave your computer. Finally, we reach the physical layer. At this point, everything is still data stored digitally. Physical layer transforms this data into signals that can travel physically. Depending on the technology, these signals can be electrical signals through Ethernet cables or radio waves through Wi-Fi. Data is converted into a sequence of zeros and ones that is transmitted using a physical medium. When the data reaches the destination computer, the entire process happens in reverse. The physical layer receives the signal, the link layer removes the Ethernet frame, network layer checks the IP address, the transport layer checks the port and delivers the data to the correct application. Finally, the application layer received the original request. The server processes it and sends the response back using the same layers. So what I've actually learned from this? Honestly, the thing that hit me the hardest is how much work is happening before you send a single byte of data. ARP, TCP handshake, TLS, 5 more round trips minimum. The code for this project is on my GitHub. You can find the link in the description. If you want to build this project, start with the TCP handshake, then the TLS to establish the HTTPS and secure connection, and after that you can start sending messages normally. So at the end, if you like the video, don't forget to like it and subscribe to the channel. If you have any questions, leave us in the comments below and tell me, would you like other networking style videos like this? And that's it for today. Bye.